Good morning students. Last class means in the previous session we discussed about number systems, that is natural numbers, whole numbers, integers, rational and irrational numbers and so on. So in this class we are going to discuss next number system, that is real numbers. Real numbers. Okay. So we know that natural numbers means counting numbers are called natural numbers. So natural numbers 1, 2, 3 etc. include natural numbers including 0 are called whole numbers. So denoted by W. 0. Natural numbers including 0 is called whole numbers. It is denoted by W. So whole numbers including negative numbers is called integers. Integers are denoted by I. So integers denoted by. Next number system is rational numbers. Rational numbers means it is in the form of P by Q. Number system is denoted by Q. So next irrational numbers. Irrational numbers means a number which cannot be represented in the form of P by Q. Irrational number system is denoted by Q dash. So next number system is real numbers means union of rational numbers, irrational. Union of rational and irrational numbers are called real numbers. This is the enlarged number system for these number systems. So union of rational and irrational numbers is called real numbers. Real number system is denoted by R. Next, let us discuss some properties of real numbers. First property. So consider any two real numbers A and B. If A into B is equal to 0, product of two numbers is equal to 0, there implies either A is equal to 0 or B is equal to 0. This is the first property of real number. So next property is commutative property. Commutative property. So for commutative property, so consider two real numbers. I consider A and B are real numbers. Belongs to R means it states that A and B are real numbers. Then commutative property under addition is A plus B is equal to B plus A. A plus B is equal to B plus A. Similarly, A into B is equal to B into A. These two are called commutative property. Okay. So next property is associative property. Next one, third property is associative. Associative property. So here consider three real numbers. I consider three real numbers A, B, C. A, B, C belongs to R means A and A, B, C are real numbers. Then associative property means A plus B plus C is equal to A plus B plus C. Here observe A plus B plus C, A plus B plus C. Here group last two numbers, here group first two numbers. Okay. Next under multiplication, A into B into C is equal to A into B into C. These two are called associative property. Okay. Next property is distributive property. Okay. Next one, distributive property. Next one is distributive property. Here also consider three real numbers. A, B, C belongs to R means A, B, C are real numbers. Then A into B plus C is equal to A into B plus A into C. This is called left distributive property. Similarly, right distributive property means A plus B into C is equal to A into C plus B into C. These two are called distributive properties. Okay. So next let us discuss next number system, that is called complex numbers. Next number system is complex numbers. Here observe whole number including natural numbers. Here integers including whole number as well as natural numbers. Here rational numbers including integers, whole numbers, natural numbers. So a real number is a union of rational and irrational. So complex number means enlarged number system for real number. Next number system. Okay. Here natural number is denoted by capital N, whole numbers is denoted by W, integers denoted by either I or Z. So rational numbers is denoted by Q, irrational number system is denoted by Q dash, real number system is denoted by R, complex number system is denoted by C, capital C. Okay. So here rational number means it is in the form of P by Q. Similarly, so complex number means a number is said to be a complex number. It must be in the form of A plus I into B. A plus I into B. Okay. A number is said to be a complex number means it is in the form of A plus I into B. Here A and B are real numbers. A and B are belongs to R means it says that A and B are real numbers. Real numbers means A and B are natural number or integer or rational number or irrational number, anything. Okay. Here A and B are real numbers. I value must be equal to square root of minus 1. Okay. So complex number means it must be in the form of A plus I into B. A and B are real numbers. I value is equal to root of minus 1. Our complex number system is denoted by capital C. Complex number is denoted by Z. Complex number is denoted by Z. Number system is denoted by C. For example, so in case rational numbers denoted by Q. So set of numbers are in generally denoted by X such that numbers it must be in the form of P by Q. P and Q are integers. Here P and Q are integers. Condition denominator must be not equal to 0. Okay. Rational numbers means simply complex numbers means the number system is denoted by C. Numbers here rational numbers in general denoted by P by Q. It must be in the form of P by Q denoted by generally X. Here complex numbers in generally denoted by Z means it must be in the form of A plus I into B. Rational number means it must be in the form of P by Q. Similarly, complex number means it must be in the form of A plus I into B. Here A and B are real numbers. Here P and Q are integers. But in complex number A and B are real numbers. Here I value must be equal to square root of minus 1. For example, 3 plus 4 into I or 3 plus I into 4. 4I or I into 4. See 3 plus 4I, here 3 and 4 are real numbers into I, or minus 2 plus I into 7 or 7 into I. Here minus 2 is also a real number, 7 is also a real number. Next minus root 2 plus I into 8. Here minus root 2 8. Minus root 2 is a irrational number. Irrational number is also a real number. Minus root 2 8 are real number. Therefore this is also a complex number. Next consider 1 by 2 minus I into 7 by 2. This is also a complex number here. 1 by 2 rational number. 7 by 2 is also a rational number. Rational number is also a real number. Therefore, these two are real numbers. It is in the form of a, means here a value is equal to 1 by 2 plus I into b. I, here b value minus 7 by 2. Okay, these are called complex numbers. So complex number means it must be in the form of a plus I into b. A and b are real numbers. Okay. So denoted by z, a plus I into b. For the complex number z, a is called the real part of z. A is called real part. Real part of z. It is denoted by RE of z. Real part of z is denoted by RE of z, but read as real part of z. Here real part of z is a. A is called the real part of z. So here b is called the imaginary part. This is the coefficient of I. Coefficient of I is called the imaginary part of the complex number z. Imaginary part. A is called real part, b is called imaginary part. Imaginary part of the complex number. Complex number is denoted by z, denoted by Im of z. Here imaginary part is b. B is called the imaginary part of the complex number, but denoted by Im of z. Real part is denoted by Re of z. Imaginary part is denoted by Im of z, but read as real part of z is equal to a. Imaginary part of z is equal to b. Okay. So consider example. Suppose consider 3 plus 4 into I. 3 plus I into 4 or 4 into I. So first denote this complex number by z. Given complex number is denoted by z. So real part of z. Real part of z means independent of I. Here 3 is independent of I. So therefore 3 is called the real part of z. Denote write like this. Re of z means, but read as real part of z. Next, imaginary part of complex number. Complex number is denoted by z. Imaginary part of z is equal to, imaginary part means coefficient of I. So I coefficient is plus 4. 4 or plus 4. Okay. So consider one more example. Minus 3 minus root 2 I. Here first denote this by z. Here real part of z. Real part is independent of I. Here minus 3 is independent of I. So minus 3 is called the real part of the z means complex number. So real part of the given complex number is minus 3. Imaginary part. Imaginary part is coefficient of I. Here coefficient of I is minus root 2. So minus root 2 is called the imaginary part of the given complex number. This question is asked for 1 marks. Either write real part of the given complex number or imaginary part of the given complex number. So consider two complex number. Z1 is equal to, so complex number is denoted by z. Here I consider two complex number, therefore denoted by z1 and z2. A plus I into b. So consider one more complex number, it is denoted by z2. C plus I write, it must be in the form of real number plus I into real number. A and B are real number. Complex number means it must be in the form of real number plus I into real number. Here write any variable, either A, B, C, D, E, F or X plus I into Y. Okay, no problem. Okay, here I consider two complex number. One is Z1, another one is Z2. It is in the form of A plus IB, C plus ID. Complex number means it must be in the form of real number plus I into real number. I into real number. Write either real number is denoted by A here, write I. Here I consider real number B. or I write here x plus I. Here real number is denoted by I. So it must be in the form of either a plus ib, c plus id, or e plus if, or x plus iy. Okay. Suppose if I want to say these two complex numbers are equal, means if I want to say z1 is equal to z2, means corresponding real part must be equal and corresponding imaginary part must be equal. For example, here real part of z1 is a, real part of z2 is c. So there implies if given two complex numbers are equal, means corresponding real parts are equal and corresponding imaginary parts are equal. So here a is equal to c, corresponding imaginary part, here imaginary parts are c, d and d. B must be equal to d. And conversely, suppose corresponding real parts and corresponding imaginary parts are equal, then given complex numbers are equal. If given complex numbers are equal, there implies, if given complex numbers are equal, there implies corresponding real parts are equal, corresponding imaginary parts are equal. Conversely, suppose if the corresponding real parts and corresponding imaginary parts are equal, there implies given two complex numbers are equal. For example, consider a complex number 7 plus 8i, and I consider one more complex number x plus iy. Then given these two complex numbers are equal, then find the values of x and y. Okay. So given that these two complex numbers are equal, means 7 plus 8i is equal to x plus I into y. So these two complex numbers are equal, means there implies corresponding real parts are equal and corresponding imaginary parts are equal. A real part x is equal to, here real part is 7. So x is equal to 7. Here imaginary, for this complex number, imaginary part means coefficient of I is y. Here coefficient of I is plus 8. Therefore, x is equal to 7, y is equal to 8. Suppose consider one more example, 1 by 2 plus root 3 by 2 into I. For this complex number, real part of independent of I means 1 by 2, real part of complex number is 1 by 2, imaginary part of the complex number is coefficient of I is here plus root 3 by 2. So root 3 by 2. So suppose consider I or 2i. Here observe coefficient of I is 2, is called the imaginary part, but here there is no term independent of I, therefore here real part is equal to 0, or this number can be written as 0 plus 2 into I. 0 plus 2i is 2i, or directly we can write here real part is 0, imaginary part of the complex number is, imaginary part means coefficient of I is 2. Imaginary part is 2, real part is 0. Okay. Suppose consider minus 3, first denoted by z. Here observe, so this can be written as here purely real part minus 3, so here imaginary part is 0, so this can be written as minus 3 plus I into 0, I into 0 is 0, 0 plus minus 3 is minus 3, therefore here imaginary part is 0. Here 2i, I is there, therefore 2 is called the imaginary part is there, imaginary part is 2, here real part is 0, it is purely real part. Okay, therefore here imaginary part is 0, real part of z is minus 3, here imaginary part of the complex number is 0, purely real number, real part, imaginary part is 0. Okay. Next let us discuss some properties of complex numbers. So before that, let us discuss algebra of complex numbers. Algebra of complex numbers means addition, subtraction, multiplication and division of complex numbers. So first consider addition. So consider two complex numbers Z1 and Z2 belongs to C. Belongs to C means Z1 and Z2 are complex number. Capital C represent set of all complex numbers. So then, consider it must be in the form of Z1 is equal to A plus I into B, Z2 is equal to C plus I into D. Then verify sum of two complex numbers addition. So sum of two complex numbers, it is also a complex number or not. So consider Z1 plus Z2. So substitute Z1 means A plus I into B plus Z2. Z2 means C plus I into D. Z1 is equal to A plus IB plus Z2 is equal to C plus ID. Next, we want to prove Z1 plus Z2 it is also a complex number means it must be in the form of real number plus I into real number. Okay. So here separate the real part and imaginary part. So independent of I means A and C are called real parts. So separate A plus C. Next imaginary parts here IB, ID. B and D are called imaginary part. Coefficient of I, B and D are called imaginary parts. So in these two terms take out I as the common term. So remaining terms are here B plus, here B, here plus D. Next here observe. So Z1 is equal to Z1 is a complex number. Here A plus IB means A and B are real number. C plus I into D means C and D is also a real number. A, B, C, D are real numbers. So A is a real number, C is a real number. Therefore A plus C is also a real number plus I into B is a real number, D is a real number. Therefore B plus D is also a real number. This is in the form of real number plus I into real number. Therefore sum of two complex numbers it is also a real number. It is in the form of real number plus I into real number. Therefore sum of two complex number it is also a real number. Okay. Next verify difference. Verify difference of two complex numbers. It is also a real number or not. Difference here also consider two complex number. Z1 is equal to A plus IB, Z2 is equal to C plus ID. Here verify difference of two complex number. Is it a complex number or not? So Z1 minus Z2. Okay. So Z1 means A plus I into B minus Z2. So minus of Z2 minus of Z2 means C plus I into D. Now separate the real parts and imaginary parts. So simplify A plus I into B minus into C minus C minus into plus minus I into D. Here real parts are A and minus C. So group these two terms A minus C. Here imaginary parts B, D minus D. So in these two terms take out I as the common term. So take out plus I as the common term. Here plus I is common, remaining term here B. Here plus I is common, remaining term is minus D. B minus D. Verify it is in the form of real number plus I into real number or not. So we know that A, B, C, D are real numbers. Therefore A is a real number, C is a real number. Therefore difference of two real numbers is also a real number. A minus C is a real number. BD are real number, therefore B minus D is also a real number. Therefore, this is in the form of real number plus I into real number. Therefore, difference of two complex number, it is also a complex number. Okay. Next, product or multiplication. Third one, multiplication. Product. Okay, so consider two complex number a plus ib and c plus id. So consider z1 into z2. Okay, verify. Product of two complex number is also a complex number or not. So substitute here. A means z1 means a plus ib into z2. Z2 means c plus I into d. Now simplify and then separate real part and imaginary part. First simplify. First multiply c plus id by a and then multiply c plus id by ib. So first multiply by a. A into c, a c plus a into id. First write I, a, d. Okay. Next multiply this term by ib. ib into c, I, b, c. Next multiply plus into plus ib into id, I into I square, b into d. Okay. Next simplify ac plus I into AD plus I into BC, here I square. Okay, we know that value of I is root of minus 1. We want I square, so square on both sides. Root of minus 1 whole square, square and square get cancelled. We get I square is equal to minus 1. So I square value is equal to minus 1. So substitute here. I square value is minus 1 plus into minus 1 into BD minus BD. I square value is minus 1. Now separate the real part. Here observe. AC independent of I minus BD independent of I. These two are real parts. So AC minus BD. So observe in these two terms we have I term here. So take out I as the common term. Remaining terms are here AD plus BC. Okay, AD plus BC. We know that A, B, C, D are real numbers. So A into C is also a real number. B into D is also a real number. Difference of two real numbers is also a real number. Therefore, this is a real number. Here AD, A and D are real number. Therefore, product of two real numbers is also a real number. Therefore, AD, BC are real numbers. Sum of two real numbers is also a real number. Therefore, this also AD plus BC is also a real number. Therefore, this is in the form of real number plus I into real number. Therefore, product of two complex number is also a complex number. So next, last one, fourth one, division. Division. Here consider two complex numbers z1 and z2. We want z1 by z2. z1 by z2. Here z1 1 by z2. Z1 1 by z2. This can be written as z1 into 1 by z2. We know that z2 is a complex number. Therefore, 1 by z2 is also a complex number. So z1 is a complex number, 1 by z2 is a complex number. Already we proved that product of two complex number is also a complex number. Therefore, z1 into 1 by z2 it is also a complex number. Therefore, z1 by z2 it is also a complex number. Here condition, z2 must be not equal to 0. Denominator must be not equal to 0. So z2 must be not equal to 0. So sum of two complex number, difference of two complex number, product of two complex number and division of two complex number or ratio of two complex number is also a complex number. Next, let us discuss some properties. Okay. So, first property, closure property. First one, closure property. Closure property means verify sum of two complex number is a complex number and product of two complex number is a complex number or not. So consider two complex number Z1 and Z2 belongs to C. Means C means C represents set of all complex numbers. So means it says that Z1 and Z2 are complex numbers. So there implies Z1 plus, already we proved that sum of two complex number is also a complex number. Therefore, Z1 plus Z2 belongs to C, capital C. So, similarly, Z1 in Z2, product of two complex number is also a complex number. So, belongs to C. This is called closure property under addition, closure property under multiplication. Okay. So, next second property is commutative property. Commutative property. So for this consider two complex numbers Z1 and Z2. So in real number, we know that commutative property means A plus B is equal to B plus C. Under addition or multiplication, A into B is equal to B into A. In real numbers we consider two real numbers. In complex number consider two. In place of real numbers consider complex numbers. Complex numbers are denoted by Z. So Z1, Z2, Z3, etc. Okay. Similarly, commutative property means Z1 plus Z2 is equal to Z2 plus Z1. Under addition, under multiplication, Z1 into Z2 is equal to Z2 into Z1. So these two are called commutative property. Next, associative property. Associative property means consider three complex numbers Z1, Z2 and Z3. Associative property. Associative property. So consider three complex numbers Z1, Z2 and Z3. Okay. So first property, in real numbers we write that A plus B plus C is equal to A plus B plus C. So here in place of ABC consider Z1, Z2 and Z3. So Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. Okay. Multiplication, under multiplication Z1 into Z2 into Z3 is equal to Z1 into Z2 into Z3. So these two are called associative property. So next property is distributive property. Next property is distributive property. So here consider three complex numbers Z1 and Z2 and Z3. Next, left distributive property means Z1 into Z2 plus Z3 is equal to Z1 into Z2 plus Z1 into Z3. Z1 into Z3. Next one, Z1 plus Z2 into Z3 is equal to Z1 into Z3 plus Z2 into Z3. Z2 into Z3. So these two are called distributive properties. Okay. Next property. Identities. Identities means we have two types of identities. One is additive identity, another one is multiplicative identity. Suppose consider a number 2. Here identity, the word itself says that identity means same. Okay. So here we want to get the same number, means which number we have to add to get the same number. So the only possibility is 0. Suppose if we add 0 here, we get the same number. So similarly, we want identity means we want same number to which number we have to multiply here to get the same number. Okay, so the only possibility is 1. So 2 into 1, 2. Suppose if you write 0 here, we get 0. Okay, therefore, so 0 is called the additive identity, 1 is called the multiplicative identity. For here I consider number. In place of numbers, consider complex numbers means write z. So z plus 0, z, z into 1, z. Therefore 0 is called additive identity for addition. For multiplication 1, therefore 1 is called the multiplicative identity. 0 is called additive identity. Because z plus 0 or 0 plus z is equal to z. So 1 is called multiplicative identity. One is called multiplicative identity because z into 1 or 1 into z is equal to z. Therefore 1 is called multiplicative identity, 0 is called additive identity. So next last property is inverse. Inverse. So we know that additive identity is 0, multiplicative identity is 1. So consider number 2. We know that additive identity is 0, multiplicative identity is 1. So here which number we have to add to get the additive identity? So reverse of this number. Here add minus 2. So minus 2 plus 2 is 0. Similarly multiplication, so consider a division. So 2 into, so 2 here, so consider 1 by 2. 2 into 1 by 2 is 1. So therefore in general in place of 2 consider z. So we want additive identity here, so consider here minus z. So here minus z, negative of that number is called the additive inverse. Similarly here minus z is called the additive inverse, 1 by z is called the multiplicative inverse. For complex number z, minus z is called additive inverse. Additive inverse. So for complex number z, 1 by z, or it is also denoted by z to the power of minus 1 means z inverse is called multiplicative inverse. Multiplicative inverse. So these are the properties involved in the complex numbers. Okay, thank you.